morning. Here we have a circuit. In this circuit we are asked to determine the value of R such that the potential difference between terminal A and B is 0. So we want to calculate R. That gives us VAB equals 0. We are going to use Kirchhoff's law. If the current here of 2 amps flow, it means that here a current of 2 amps flows as well. Because it flows in this direction, we have VR2 in this direction, because this will show the highest potential, and VR2 we can draw it like this. And now if we want that VAB, which is VR1, should be in this direction, if we want to have VAB equals to 0. So okay, so it means that if we want to have VAB equals 0, we can write in this direction VAB plus VR1 is equal VAB plus VR1 minus VR2 is equal to 0. So it means we can write the following equation. So it means that VR1 should be equal to VR2. VR1 is R1 times ER1 should be equal to R2 E. So it means that R1 is 5 ER1 should be equal to 3 times I. So it means that ER1, we can calculate this, it's 3 times 2 amps over 5, and it's 1.2 amps. So it means the current that flows here is 1.2 amps, and here flows 2 amps. That we can write, we know now that the current that should flow here, ER, should be equal to 1.2 plus 2 amps. So it means the current that flows here should be 3.2 amps. So we can draw the voltage drop VR in this direction. So now we can write in the clockwise direction, we can write that the algebraic sum of the voltages is 0. It means that if I write minus 10 plus VR1 plus VR should be equal to 0. So R1 is 5, so minus 10 plus R1 times 1 over 2, which is 6 volts, should be equal plus R times IR should be equal to 0. It means that R times IR should be equal to 10 minus 6 should be equal to 4 volts. R should be equal to 4 over IR, which we have calculated here, 4 divided by 3.2. It means that R should be equal to 1.25 ohms. And this is the solution. And thank you very much for your attention.